Yeah, welcome everyone. This is our first ever office hours in Fabulous, and we wanted to uh, start doing these sessions because we really want to make Fabulous the best thing possible for us, the best UI framework on .NET that we can use. So we will be more active in terms of telling you or sharing with you what we are thinking, what's our plans in the short term, in the long term. And now that Timothy and I are working on the same company and we are using Fabulous day to day, we are improving Fabulous day to day, and we are even dog fooding Fabulous with our app. It's really good. So yeah, without further ado, the topics that we want to cover today are, first of all, a quick recap of what's the current state of Fabulous at the moment. We will explain you a little bit of what's the purpose of the office hours, and also a little bit the move that we made Fabulous from the F sharp FS projects to have our own organization now. And we'll also talk about the short-term state for Fabulous 2, because now Fabulous 2 has been, I think, almost 6 or 7 months old, and we are really happy with the state of Fabulous 2, and that's what we are using at the moment in our day-to-day, and so we will be sharing with you some short-term stay there. And then we will talk, I think, the most exciting part, which is what we want next for Fabulous on version 3, which I will, Timothy and Simon, and, I will go deep on, what we can do, what amazing thing we can do for version 3. So, yeah, Tim, the floor is yours now.
Yeah. So let me share my screen. Okay, you should be able to see it. Let me know if it's not the case. So I just wanted to start with saying that Fabulous has a new home. Now it's in its own organization under Fabulous Dev on GitHub. So here you can find everything that is related to Fabulous, and also some repositories that are mainly helpers for us to build apps in F#. So you will find Fabulous. Also, we splitted the main repo. Before, everything of concerning Fabulous was inside the same repository under the Fabulous one. So now we extracted everything that is Xamarin.Forms has its own stuff, and same for Maui and same for Avalonia. So you can find all that is related to Fabulous in this repo, in this organization. So feel free to explore. So the main one is still the core of Fabulous. So I also updated everything, like all the README, all the contribution guidelines, stuff like that. So you can find all the implementation, saying like for Xamarin.Forms, you have Fabulous Xamarin.Forms. For Maui, you have Maui control. You also have Fabulous Maui itself, which is currently WIP. The idea is to use Maui in a way that we don't rely on the MVVM part. So still undergoing. And finally, something that Edgar is working on is to support Avalonia with Fabulous. So this one is still work in progress. But basically, it's all of them are all supporting the same syntax with the MPU architecture, so init, update, and view. And in the view, you have access to the declarative syntax. So each implementation will have its own set of widgets that correspond to the one of the corresponding frameworks. So here is the application content page of Maui. And finally, it for this one. So we are also reworking the website. So this is something that will come later. I will talk about it. So for now, it's not great, but this is the plan. And also one thing that I want to mention is that Edgar, that just introduced this office hour, is also joined as a organization administrator to the Fabulous organization. So welcome to him. And so like Edgar mentioned, now we are working full time with Fabulous for a real application. So like we've been working for several months on a Xamarin Format application, and now we are currently migrating to Fabulous microcontrollers. So for now, Fabulous microcontroller is a little bit rough, but it will get better as we dog food and bug fix all the stuff, and also the tooling will improve. So voila, and to finish this part about the current state, just wanted to make a short demo to show like where to start. So basically, you will need to use the command line to install the template. So with .NET New install, and then depending on the flavor you want, Mindful, Maui, or other, you will have access to the template. So when you install it, you will have the template available. You can just do .NET New name of the template and say we want to make a Fabulous Office Hour app. We can just do this, and now it's already created. So if I do if I go in this order, you can see that everything has been created. The F shop. So since it's a Maui application, we are using the single project structure. So with only one FS project, you can target multiple platforms, iOS, Android, and others, so depending on what you select. So it's nice. And let's open it. So, okay, loading. So the tooling supports more or less everything that is about Maui. We still have quite a few issues with it, but it's not related to Fabulous, it's related to Maui itself. Let me increase the size. Let me know if you see correctly. Okay, so let's just build it quickly. Okay. So the first build will always fail because of Android. That's something they fixed in .NET 8. So we still need to wait until the end of the year to not have these issues an issue anymore. Basically, it's because of the resources of Android. It needs to compile twice to grab them. So for all its building, so we can find like the MVU structure if you're already familiar with other Emish like frameworks. You will recognize it with the model, the messages. So this example is using command messages to enable like better unit testing. So testing functions instead of testing side effects, you only have to test against discriminated union. And so you will find the usual init, update, and view function with all the declarative syntax. So we have the widgets. So basically, widget is like a component that you will display on the UI. Like say you want a label, you will be able to do this. And those labels, like those widgets, they come with modifiers. So if you say, actually, I want the font to be of size 12 pixels, you can do this, and you have access to all of them, to all that will support it. Like you can have background, you can have opacity and stuff like this, and you also like shorthand to say like this one I want it to be centered both horizontally and vertically. Okay, so apparently it's already running. So we have the app that is running. Just let's make a quick example. So if you want to say like, okay, my the count is, and you can just reference the model and say like I want a button that says increment, and that will trigger the message increment. Then for decrement, you just need to change the message. Saying that I want this one and this one. Increment. It was already count +1, so it's good. Let's do this one, decrement. Let's do -1. So here we don't have a hot reload mechanism yet because it's not supported in F#. So that's something that we would like to have, but it's actually quite hard to achieve. So we'll talk like at the end of this office hour to see if we can do anything about it. But yeah, so we have the count. We can increment it. We can decrement it. So it's good. And you can even center. If you want, you can center it horizontally, and then just by reloading, you will have it. So voilà, it was just a quick demo of the current state of Fabulous 2. So there is way more to show, but it was just a to start with. And now the label is centered. Okay, so this was it for the current state of Fabulous. Now I want to talk about like first off, like is there any question about the current state of Fabulous? No, we're good. Okay. So now I want to talk about the short-term plan that we have for Fabulous. So still about Fabulous version 2. So like I mentioned, the Fabulous website is quite in a sorry state. So that's something that we want to work on to be basically able to have a proper website with real content, and also we want to do all the documentation. We have some documentation, but it's not enough today. So that's something we need to focus on. So for the coming months, it's what I will be focusing on. So yeah. So what else? If maybe we will need some help from the community. So if anyone is willing to join us in this effort of making a website and inviting more documentation. I know that's not very sexy to do, but that's something we are clearly missing. And voila. So maybe Edgar, you want to talk about Fabulous Avalonia, what's coming for it?
Yes. So for Fabulous Avalonia, we want to. So Fabulous has become a really powerful library in terms of creating a UI DSL for almost all the frameworks of Fabulous. Now we call it Fabulous Core. Is you can basically wrap any UI framework that is in .NET. You can call it Forms, Maui, Uno. If you like Uno, you can implement even using Fabulous. You can implement whole range of widgets from Uno. In this case, we did it for Avalonia because Avalonia is getting a lot of traction and it has a lot of hype in the .NET ecosystem, and we believe it's also a win for us to be able to support Avalonia. So the plan for Avalonia is to offer the same experience that you are getting from Xamarin Forms or from Maui controls, but using the Avalonia improvements, the Avalonia specific widgets for desktop and for mobile in the upcoming I think version 12 that they are going to release, and they're also going to do web, so we might also be able to support a web. And what Fabulous will do is just take those widgets, wrap it, and offer you MVU support, and also give you the declarative syntax. And so what you can expect from Fabulous Avalonia is to cover the widgets that the Avalonia UI is offering you, and with some limitation, of course, but because Avalonia UI is a really SAML-based framework, so everything that you can do it in SAML. But some of those controls are difficult, really difficult or tricky to wrap. So, for example, data templates are not really a concept that are really that play nicely with Fabulous. So in those cases, you will need to construct your data templates in a different way, using more like a Flat a way of doing that, or a Swift UI way of doing that. So at this stage, Fabulous Avalonia is work in progress. I think I have 120 control reps of 160 or something like that. So yeah, we are getting there, but yeah, we need to also make sure that we have the templates available. We need to make sure that we have the documentation for that. And before we release the first version of Avalonia, we want to have a place in the fabulous.dev where we can show you what is the aim of Avalonia and the Fabulous Avalonia, show you the API reference and maybe some tutorials. But the Avalonia UI team has done an amazing job already of documenting their API reference and their documentation. So what we don't want to do is re-implement that. We're trying to have the F# version of those. So we will encourage you to use their API reference, because it's going to be almost exactly the same that the one that we can provide. But what we want to do is provide you with the F#, let's say, with the F# version of that documentation, so you can see the function definitions and see exactly what you're expecting on. We have 2 contributors more in Fabulous Avalonia that they are from time to time, maybe once or twice a week, they raise a PR to add controls on Fabulous Avalonia, which is really nice, because it means that there is some interest on that. So yeah, that's the plan. Hopefully it's clear. If not, feel free to ask me any questions.
Yeah, if you have any question, not hesitate, both written or if you want to speak. Okay, so if no one wants to ask questions, maybe we can just skip to the long-term plans for Fabulous. So Fabulous 3, most likely. So let me switch to this link. We'll share it in the Discord if I can. I guess you can also access it. So this one, open chat. So this issue is where I wrote about what the goals of Fabulous 3 should be. So basically just for 3 points, but you will see that those 3 points imply a lot of work potentially. So the first point was to give Fabulous a strong independent identity. So today, like you saw just for the presentation, you can choose either the Fabulous the main form, Fabulous Maui, Fabulous Avalonia. So it gives this identity to Fabulous that it's there to make an existing UI framework functional with F# and MVU. So this is great, because we can appeal to people that knows F# or that wants to learn F# and that wants to make a mobile application using .NET. So this is good, but it's also a limited number of people, because they need to be both wanting to use .NET for their mobile application, which is already a small number of people, and they also need to be interested in F#, which is an even smaller number of people. So we see some potential for going against Flutter and SwiftUI. I'm not saying that we will be able to compete at their level, but at least there is a space for a declarative UI framework that is based on .NET. So this is something that we could put Fabulous like in this space to give it like a strong identity. And for this, I think we also need to be able to separate ourselves from existing UI frameworks. So Fabulous won't be anymore F# for Xamarin Forms, F# for Maui. It will be its own independent thing. So this was the first point. So like some ideas to how to achieve this was to provide like basically something like state-of-the-art declarative capabilities. I wrote. It's basically today we have an issue with Fabulous like version 1, version 2 is we are working against frameworks that are meant for MVVM and for XAML. So to make them compatible with a declarative approach with F# and MVU, sometimes it's a little bit complex, sometimes like almost impossible. So like to be able to get to the next level, I think we need to create our own widgets, not rely on what is existing today in the XAML frameworks, and create our own widgets. So this can include like specific widgets that are meant to work only in a declarative space, or maybe a specific layouts, so it's easier to lay out in the declarative way. And also we need to start supporting animations and theming. Like the underlying XAML frameworks, they already support animation and theming, but they do it in a way that is specific to XAML. So we need to find a way that will work in the declarative environment. And today it's quite hard to actually put them to map the XAML one to the declarative one. So it could be also required, I think, to implement our own animation engine and theming engine. So second point was what I was saying. We basically need to advertise Fabulous on its own and not depend on other frameworks. Even though we can still use other frameworks behind the scenes, but Fabulous will need to be able to advertise on its own to attract more people, especially if people comes from outside the .NET ecosystem. It will be maybe more like appealed by something that is advertised on its own. Same for F#, because there is a big fight between C# and F#. Both sides are firing against the other side. So it would be nice also to say like Fabulous is for we use Fabulous for the functional programming approach to it, and also because we support well object-oriented programming, which will be compatible with the rest of .NET, and not say just we use F# because we like F#. It will need to have its own reason. So yeah, so this was for the first point. For the second point is basically improve the whole development experience. So like basically like everything that said about the state-of-the-art declarative capabilities, to have our own widgets, our own layout, our own animations, theming, and also environment, and to be able to put data in the environment of the application and just be able to consume it, like independent widgets. So third point is something that we will discuss, I guess, is to should we make the move to drone UIs? Today, since we are relying on the Xamarin Forms and Maui, we are using native UIs, but there's like several issues with it. Like we have a lot of inconsistencies, controls that behaves differently on different platforms that don't even look the same. So I guess if we want to advertise Fabulous by itself, it means that people will expect it to work the same on every platform. So I guess we will need to use it with drone UIs. So we still need to see like how to achieve this. And last point is to basically continue to improve the performance. So with the help of Simon on version 2, we did a lot of work on the performance. basically like make it use only struct on the hot path and make sure that we don't have any like in virtual dispatch and stuff like that or cache miss. So we still need to continue on this. So voilà, that's all for all the goals of Fabulous 3. So one question was asked about do we have plans for hot reload? Unfortunately, not really, but we can still discuss if something is possible. Okay, so maybe we can discuss like how to achieve like some of the declarative capabilities and how to structure the architecture if you want. Simon, do you have already some point you wanted to discuss?
Actually.
No?
I heard, or at least I think so. Do you hear me? Yes, no, maybe?
Yeah, okay, good.
I'm sorry, the browser is not really catching up to my headset. So ideas or statements, not necessarily mutually exclusive or whatever, but I have. So once I think that if we can afford it, we should have our own UIs. And what I mean by that is the success, for example, of Flutter is when actually, having the same UI and the fast drawing capabilities is good. And Flutter is popular despite Dart being like not the best language ever, right? And part of it is that consistency and also the pace that they allow themselves to actually execute because they control the entire drawing stack. The downside of this approach is, of course, you need to have like accessibility, focus selection, text input, interaction with a keyboard. For example, you click on a text field and like keyboard pops up, right? And have to do all that themselves. And so, sure, let's draw it. And there are advantages to this, but also what they took is Skia for rendering by itself. Like it's a lot of kind of heavy done for them, including text rendering. But text layout is another issue. Text layout actually is like are often issues and text rendering. They took a hear me? Yes, no? Okay.
Yeah,
So
it's cutting from time to time though.
text. Sorry.
Yeah, it's cutting a little bit.
Engine out of. No.
While Sam is coming back, I think I've been doing mobile development for 5 years now, and I saw the the idea of native UI is really the best thing to do. But the last 5 years, I have seen people or most of the frameworks going against the native UIs and really trying to develop a consistent UI between both. And even the .NET team now is playing with something called Aloha Key, which is they are now developed something called Microsoft MAUI graphics or something like that. That they are also planning. They are looking at allow you to draw UI. So I think for the new cross-platform era that is coming, I think drawing UIs is a approach that is going to be gaining more and more attractions, and for us in Fabulous, I think will be a way of provide a consistent UI rather than having to deal with both platforms. That is sometimes really painful to them.
Yeah. So like in .NET, I saw that Avalonia is doing it like fully, but it's only starting now to support mobile development. And Uno, on the other hand, is only using Skia to draw on several heads, like mostly the Linux one. But everything that is mobile development, they are still using native controls. So I don't think any .NET framework are using Skia or anything else to render on mobile today.
Can you hear me now? Yes, no?
Yeah.
Awesome. Is it better?
Yes, way better.
Awesome. Yeah, to my knowledge, no Skia. So anyways, the point I was trying to make is that if you can afford it, I feel like going Flutter route is a better approach because it will give us more kind of freedom, flexibility, power to do stuff. For example, in terms of performance. On the other hand, it's a lot of work, and by a lot of work, I mean like a lot of work. And like in my mind, essentially that it requires funding. And by funding, I mean like actual legit funding, not kind of labor of love funding, like, you know, a company, so to say. And so at least that's my feeling about this. I might be wrong, but that's my feeling. So, and then, okay, if that is not an option, what can be done? And I took a look at the Avalonia rendering layer. So how is that kind of the structure specifically putting pixels on the screen? And like, and the intent was, can we decouple that, draw calls from actual, controls? Say, okay, can we just take the drawing code and like just put stuff on the screen ourselves? And I found several issues with this. So one of it is the code is kind of coupled. So there's like intent to actually decouple this. Like there are like brushes, abstraction on top of like DirectX or Metal or whatever, which is good. On the other hand, it feels to me that they're kind of like designed or co-designed to kind of together, like to work with Avalonia specifically. And the reason I'm saying that, I looked like at the code, like, so service locator. In service locator is, if you don't know, the pattern is like it's a singleton that you just put stuff in and then ask stuff out. Means that there's like some piece of code that's supposed to put a renderer in the service locator, in like somewhere else, you don't know where exactly that piece of code is going to be used. In my opinion, is not necessarily like the best architecture, but they have it. And so what that means in practice is like, we'll need to understand way more into the way that works, because there is no clean layer to say, take this, that's your render stuff. Above this, it's your, I guess, controls layers. Like there is no clear semantics about this. And
so, like if we go one abstraction above and we just use basically the Avalonia controls, like could that be enough for what we want to do?
So to what I looked at, the answer is no, because basically the layer above is kind of, I don't want to say cohesive, but they're kind of coupled and say, okay, you're kind of buying into the entire thing. And they have like a kind of smaller pieces that they decompose, but essentially it's not designed to be used in different architecture anymore. It's like basically layer above, you buy into layer above. That's it. For example, the one that the work Edgar is doing right now is probably like the only actual approach to use Avalonia. It's like, okay, I'm going to buy into the entire stack of Avalonia stack and then kind of only interact with the API surface area. That is probably the only legit approach. Maybe other approaches are possible, or like layering is possible, but I didn't see like a kind of easy opportunity to say, oh, here's a clean dividing line. Basically, like you have to really dig deeper, understand better. Maybe submit PRs, maybe make a fork or whatever. But like, I did take a look at the drawing specifically. In drawing by itself, actually, is the easy part, because at my day job, I do kind of UI engine in Rust, and I did all the drawing myself too, like including triangles, shaders, and whatnot. And so it's not that hard. The hard part is actually immediately layer above, specifically input, text layout, text selection, rich text editing, stuff like this. Like kind of like, it's not control, so to say, but like kind of one layer complexity up from like drawing pixels on the screen. And so reusing the bottom part, the pixels, it can be done with Skia, or maybe I can do it like, with triangles and like shaders. It's not like that hard, doable. The text input, focus, accessibility, that's what concerns me the most. And that's where I see like the black hole of effort that needs legit funding for that. Basically, you need to have more than 2 people full-time working on that thing for some time.
So, like, how did Avalonia achieve it? With funding, or is it just took their time?
That's a good question. I don't know the history. So one, desktop specifically is easier than mobile. So touch is harder to get, and also touch and keyboard interaction, like, when you select the text box, keyboard pops up. That interaction is easier on desktop, whereas on mobile, that even like I can arguably do like maybe in a couple of months myself, using some primitive technology, like, some APIs. What is hard is like to make it cross-platform. And so Avalonia started as a desktop, which means like it's a slightly easier problem to tackle first. And then they did have time. So Avalonia was not built like in one day or like 6 months.
Yeah.
Like it took them time. And with time, of course, you can like do all sorts of things. And I feel like, I don't remember where it started, but it was a while back that it started. But only in 2022, they released the first version of for mobile, if I'm right, if I'm not mistaken.
Yeah.
So it took them a
preview,
while.
I think.
Yeah.
Still in preview.
Yeah. Because it's hard. Like that specific thing is hard. So Flutter did start with mobile. So Flutter is a mobile first, and then they transitioned to desktop. And transition to desktop for them was like half a year kind of effort, like 1 year effort. Like for them, it was easy, or like easier, because it solves the hard problem first, which is mobile input.
Yeah, the fact that Flutter was designed as a game engine, to be honest, so they had everything from scratch. So they were a legit game engine. I remember, I don't know, 5-6 years ago, it was called Sky, where they were building games with that, and then they decided to, make the move to cross-platform development, and they use all those resources. So they are.
Good question. To my history, or to my knowledge, and like I did follow Flutter for like, from the conception, or at least I think I did. It did start it as a hackathon for Chromium, for a Chrome rendering engine. And then basically the idea was like, okay, Chrome as a rendering engine is good, but like so much craft that it was kind of acquired over time. For example, there were like several websites in the world that use specific CSS property and like the if in the rendering engine, and that if like kind of 0.5% of the performance for like, frame. And they have to do that because, well, you can break them. And the goal was for them, for the hackathon, is to like, what if we remove all the ifs that we know that are harmful, how faster we can, like, we can get it render stuff. And so if my memory is right, the hackathon ended up with a 20x improvement over rendering in Chrome. So like, okay, we actually should do something about this. And so it's like we already had a technology first, that there is like a really nice technology that we can render stuff, and so where it is applicable. And so they decided to explore mobile space. But to my knowledge, they started as rendering engine first, then they search for scripting, so to say, and so they explored JavaScript, but JavaScript was not good enough. And for whatever reason, they chose Dart. I don't know. I don't know why. But they did it. And so that's kind of the conception of it. Like, we need to put, like, we know how to put pixels on the screen, and like where we can apply that. So like we kind of cheated a little bit. part of the reason is because they had really good funding out of Google.
Sure. Yeah.
They can cheat. So, so to finish the thought about rendering, or like taking the painting approach, I think it requires a little bit more research, but the part that worries me the most is not putting pixels on the screen. It's more about like kind of immediately layer above, as I said, input control, interaction with the platform in terms of like keyboard navigation, text selection. That is like really hard problem in itself. And I don't know if you can take a Bologna part of it and just like, oh, by the way, I'm going to take only that part, and all the other craft of Bologna has in terms of like MVVM and their architecture, like we're going to leave it aside. I don't think that is possible, at least to my understanding. And so it's in like, okay, what other choices or what kind of options do we have, right? Like in terms of give it our own identity. And here's some ideas that I have. I'm going to throw it out with you. I don't have like a specific vision, so to say, but like here's my brainstorm kind of quality of ideas. The one idea is we actually can start with rendering stuff at the lowest level if we limit a specific platform. For example, say, oh, you know what? Let's not start with like mobile and specifically iOS and Android separately. Let's pick one that is easiest to implement. For example, be it desktop or whatever. Not web, because web is actually really hard in terms of accessibility and stuff. Or, for example, one of the things that is really interesting is embedded UIs, meaning like you have like a Raspberry Pi screen, or you have options like game UIs, because game UIs is actually a really pain in the butt. Maybe Unity, for example, is like a really good target for this, because UI in Unity sucks. Actually, they didn't release their own kind of MVVM in Unity, but the point I'm trying to make is that we can take that approach of rendering, taking the full control, if we limit the scope to a more manageable chunk. You know, like say, okay, we start here and then expand. But to my understanding, both right now you're employed by a company who is interested in building UIs for mobile. And this is the hardest platform to target. So maybe that's a viable approach if we can scope it to different platforms than mobile, and the platform is small. Game UI is a good example of this. Other idea is to say, okay, what we can take to put stuff on a screen that will have some sort of resemblance of like accessibility, and yet kind of pursue that goal of removing layers, so like, you know, removing chunks. And I think that our best bet, at least in my opinion currently, is to basically take what Maui tries to do and do it differently than that. And that might sound real ambitious, but in reality, it's not. Well, like not as ambitious. Specifically, I'm looking at React Native because I know the history of React Native, and I know the conception of it, and I know, like, I did look at the code, and like, you know, I did work with React Native professionally as well. So one statement I want to make, like, React Native, its conception is just total crap. Like, it was barely a hack done by, like, I think 4 people, and it's used in production at that stage. Like, it's the early stage, it was done by 4 people, and like, sure, what can go wrong? Like, you know, move fast and break stuff, and it was not good. Yet they did use it, and so one of the reasons that they kind of were successful at kind of bootstrapping that effort is they reused platform primitives, meaning that they reused views or enhanced view on like iOS or whatever, and Android views. And essentially they said, like, you know what do we need to build mobile applications? And essentially, if you boil it down, you need like really small things. So one, you need layout. Basically say, I need to express complex layout, like Flexbox was an answer to for them. And like, that's it, you're going to only do Flexbox layout. The second part that you need is essentially say, I have a rectangle, maybe rounded corners, and maybe with shading or whatnot. So basically say, okay, what is a primitive on the platform that supports drawing as a box, and like NSVU is the answer to that, on iOS, right? Other thing, but you can hear me because I see, like, I hear some feedback that are almost like, anyways, I'm sorry. Or the technical issues. Other things that they said, okay, after you have like boxes on the screen that you can color in, like, maybe size properly and layout, what else do you need? And text is another one. Text input, yet another one, and images. And like originally React Native, like basically was that like text, images, boxes, and text input, of course. And of course, like checkboxes and whatnot, but these are kind of like the easy part of it. And so basically, with like really small subset of primitives, you can build pretty sophisticated UIs. And then, of course, you need like animation system. They build their own animation system in React Native. So basically, kind of declarative animating layout engine. Basically, say, okay, here's the functions, essentially. Like you pass functions to the engine, and the engine say, okay, now that function is attached to like a actual underlying platform view, or whatever primitive platform has, and like in a separate thread or maybe in the same thread, we know how to interpolate them. In some of the functions are natively supported, meaning that you don't have to run JavaScript to actually animate stuff. And these ones are fast, especially if you don't need to recalculate layout. For example, like offsets, alpha, these are like really easy because they don't require full layout of a page. And basically that's kind of it. Like, opacity, offsets were like, for a lot of people, kind of enough to express stuff. Scale also does require layout. So I kind of like really a little bit familiar with like API and stuff like this. And like, I'm kind of confident that it is feasible to do what React Native did, or what Maui did in .NET space. And like one of the things that is really hard to do in that kind of UI engines is actually to have a DSL to express UI. Like, okay, you have your native primitives and whatnot, but how do you actually express your UI? And actually in here, we are covered. Like Fabulous too, I feel like it's a really good experience as a whole. Like, I have nothing wrong or like nothing against like Fabulous too. I think like a fabulous experience besides hot reloading. And so we have the hard part of dev experience. We have some part of it done by, kind of Maui Essentials, or Uno actually did the same thing with like platform primitives. Meaning like, okay, here's a platform, but it's not UI, but it's what the platform can do, right? Like, notifications, accessing, files, or whatever, like kind of IO that the app can do. Like heavy lifting actually done, because like both of them, to my understanding, is like kind of did a really big heavy lifting to actually reconcile all the platform differences and say, here's a API that like available for all of them, for all platforms, which is also good because that's a hard part in React Native. That was one of the hardest parts. Like, okay, how do you actually access some native capabilities for platform? And because it's a JavaScript, they had to go through the bridge. They had to expose the API, native API, through the JavaScript API. And because the old architecture required like JavaScript to run in a separate thread, they actually had to serialize all the commands into JSON, parse JSON on native. And like that was back and forth, was really hard. And so for them, it was like a really hard challenge. We don't have that because one, there's one runtime. There is no bridge to this. We just can pass references around or like pass data around. Like there is none. Second part, there's already APIs, or already open source work that we can use. So, and that basically leaves us, if say, okay, we are going to pursue binding to whatever native primitives platform allows. And yes, they're going to be unique per platform. Likely, iOS allows you to compile to Mac Catalyst, but let's assume we have to support this too. What else? And layout engine is another one. And part of the layout engine, you need to have a text layout. And text layout is kind of tricky because if you say, okay, I'm going to use native primitives to render text, you have some layout because they can measure stuff. And like measuring stuff is like, that's hard. And so that is still a not insignificant challenge, how to integrate text wrapping, text layout, like line spacing, whatever, into layout engine that is usually separate. But it's way easier than, do the Flutter route because Flutter did like the hardest way possible. Now, what actually I want to say about specifically React Native, and which I actually really like what they did. And so they said like, okay, actually there is no shared layout between iOS and Android. Like there is no shared API to do layout for them. Let's throw it away. Like, let's not do layout anyhow using native primitives and use separate layout engine that they wrote in C called Yoga. And basically what we do, we say, here's a native primitive NS view, and NS view has exactly the size that I want in exactly the position I want. In either local or absolute coordinates, you can have both. And so what they did essentially is like, okay, let's create 15 NS views. Let's locate them on the screen. And not just locate like this one goes after the other. Like you say, you go to like position 5.5, you go to position 15.5 or whatever, because they did layout separately. So if you say today, like Simon, you have to make a call, like what route we need to go to give Fabulous its own identity, I would say we need to go with the React Native route. So we have advantage of this because, so one, there is no bridge and we have UIDs already covered. So we have that. We have we have APIs that are available for platforms that is cross-platform, MAUI Essentials, for example. We have already kind of .NET bindings for each platform, right? Like .NET iOS, .NET Android, whatever. So we have that. So what we don't have is kind of mapping for like, okay, here's a, let's say view, here's a vertical stack, here's a whatever, mapping into native controls. That needs to be built from scratch. Other part is missing is layout, because if you're talking about cross-platform layout, for example, MAUI has its own layout engine, which is the .NET is actually kind of slow. I did take a look at the code. It won't compete like with Yoga, for example. And then we need to also kind of basically understand how to integrate text and text input into layout engine, which is not easy, but in my opinion, doable. Now, the biggest problem with that is like, if you say we support Android in iOS, that work needs to be done twice, right? Literally twice. But in my opinion, that is probably the most doable, realistic approach. One thing I want to mention about React Native specifically, even though UI is actually driven by JavaScript, and also if you don't know, on iOS you can't use JIT, or of course you know, because you need to compile ahead of time with Mono, right? So it has the same issue. So JavaScript was interpreted, and interpreted React Native applications sometimes, and even oftentimes, are faster than their kind of native counterparts. The main reason for that is layout, because layout on native platforms is slow. And it can take like a huge part of it, like a huge part of the frame. And so essentially eliminating layout as a part of the rendering flow, and also they did layout was initially on a separate thread. They basically allowed to have really fast apps written in JavaScript that is interpreted, not JIT compiled, interpreted. And so if you think about this, what if you can do kind of the same, but instead of like slow JavaScript and have like bridge and have like cost between like JavaScript go to native, that's really costly. We just can write everything is like in F# or .NET. And I feel like that is not like a bad proposition in my mind. It's pretty appealing. Essentially, occupy the same layer of ecosystem as like Uno or Maui in a way. So basically say, okay, conceptually, we are a replacement for this. Like not replacement, like occupying the same kind of semantic space. Because Maui actually does the same thing, like in Maui way, like in the MVVM way, but also they have to deal like mapping like between like Maui controls into native controls. They already do that. Actually, we may take a look how to do it, but it can be done. That's my point. I don't see how rendering controls, like ourselves in terms of like pixels and shaders and stuff, can be done on mobile platforms without funding. At least that's my opinion.
So what you're saying is basically, to replace completely Maui just with our own implementation, and directly use the like all the native controls and position them ourselves.
But not all. Actually, that's a really interesting part about this. If you look at the React Native APIs, there are 5 primitives that they have, like view, scroll view, text, label, or whatever.
So you're limiting yourself like the work for basically you're building yourself with just some primitives, but all the more advanced control you don't use them.
React Native, yes, it doesn't. So it allows you to kind of say, okay, if you do need to use native controls like this, they allow you to kind of add that on top of this. And basically, that's what we allow to do. For example, with Avalonia or whatever, like you can register your own widget, right? Like you can do that. And so basically out of the box, they said most of the UIs can be done with like really small subset, like first class subset. And then if you really need native platform stuff, you have API to kind of wire it in, to plug it in. By the way, in React Native, it's ugly. It's not great. In Fabulous V2, like binding native controls like on top of like add bindable properties on top of it, just glorious relative to what React Native developers have to go through, because they have to write C++, they have to have some magic in terms of like serialization, go through like translate JavaScript data into C++. Like it's just ugly, and so that's the route that they choose, and partially because of that, it's kind of like, I would say, more successful than any other frameworks that I know. Because like, oh, I can't do that. And like literally there is nothing like React Native you cannot do if you can do that on native platform, because they allow you to tap into all the native capabilities. It's ugly, but you can do it. And like for bigger companies, for example, like really key for adoption, say, okay, we need to do this API, we need to use this, encryption or whatever, that is like really specific to like, whatever version of Android they use or whatever, right? Like they can do it. And so for a lot of companies, that's a no-go conversation, say, here's a limited subset, and if you want to do anything else, good luck. For example, Flutter is like that. And Flutter has like a really big issue with adoption. For example, say, okay, how do I integrate video or YouTube into my Flutter app? And the answer is like you can't, because Flutter actually wants to draw every single pixel on the screen. And so basically adding video control on top of this would require kind of propagating that knowledge all the way through the rendering stack back to Skia, and say, Skia, by the way, here's like one draw call to like draw UI, and here's another draw call to draw video frame. You need to pass video frame. It's ugly. And so in React Native, you just bind to video control and like you're done. In Flutter, it's ugly.
Okay. Yeah, I think it's definitely a better way of doing that than to create our own rendering engine and then have to deal with all the accessibility, text layout, and stuff like that.
Don't get me wrong.
Yeah.
I actually would love to do that. Actually, that's one of my dreams, actually, to get paid to do kind of this stuff. Like, I really like pixels, and like really like, putting pixels on the screen and stuff. Like, I really enjoy that, but I don't think it's a doable approach for open source project per se. Or maybe you already talked to investors and you have 50 million seed funding, then maybe we can have a different conversation how to spend those, but I don't.
Yeah, I guess if we manage to do that, it will be like in the future if Fabulous 3 is successful and we get a lot of users and we can get some funding. But for now, I guess we are on our own and to do what we can.
I mean, what Fabulous has achieved in the last 5 years is been. I mean, I started using Fabulous 5 years ago. I remember the first version. You navigate from one screen to another, and it takes me the app 3-4 seconds to navigate, and it will crash. And now it goes really smooth. So I think the kind of the progression from my point of view has been really impressive. So I think we can have some achievable goals that going to a more challenging approach where we can have a own identity. It will be ideal, and I think we can get people like yourself and more in the community that we can help us to do this. And from what we can do in our day to day, we can actually prioritize work that we can do for Fabulous because we are using it. And if, for example, a Fabulous version 3 goes in a state where is it usable in production, we can even use it in our app and dog food it and get more funding or get funding to actually maybe contract a person like yourself or other person that who can help us achieve those goals. But we cannot go from zero to hero in couple of months or I guess in a year. It needs to be a small step by step slow progress, but yeah, that's our intention.
Also, I would say that funding climate right now, at least in the States, is a bit lacking. And to my understanding, UK is not in the best shape economically as well. So like, oh, by the way, you're going to do open source UI framework. Could you give us money? A lot of money? Yes. Like that's not going to happen in a year or two for sure. Economic downturn is hopefully going to be not as severe, but it's going to be pronounced in terms of like funding possibilities or opportunities for sure.
Right. It will be more like to lay the foundations, of what we want to achieve. We are happy with Fabulous version 2, and I think we can still keep improving short-term Fabulous 2, but what we want is to have your identity, something like a version 3 will be something that will give us that next step. But yeah, it's, as you say, it's a difficult times for everybody.
Yeah. So one thing I want to say about specifically the route that at least I'm suggesting or offering, I guess, is that specifically React Native has a really small subset of stuff. I think it's accidental, but also kind of on purpose, because like the API service area in terms of like what you can put on the screen is small. If you take Maui, for example, you have frame, you have button, you have image, like you have like, how many did you mention? 150 controls for Avalonia? Like, maybe it makes sense, but I feel like it's also become a little bit excessive, at least for most applications. And so my opinion is that if we choose to not copy paste, but kind of like be really inspired by specifically React Native, because Flutter is a bigger surface area than React Native. Flutter is larger. So if you say, okay, we're gonna not copy, but like copy when it makes sense, the APIs and controls, like when I'm looking specifically maybe at view or button or whatever, those are probably doable, like at the start, because there are not many of them. If you say we need to support 150 native controls, it's not okay to actually do it twice. For example, probably Avalonia can afford to do that because for them, they do control the rendering stack, meaning that they don't duplicate code for each control for each platform. They may have rendering specifics, but they don't duplicate all the hard work. If you buy into the idea that you do need to copy paste, not copy, like support two platforms, and these two platforms are two separate implementations, you need to limit the scope as much as possible. In my opinion, React Native did a good job at that because they kind of were born with this constraint. And also, they started like a long time ago. 2014, I think that they were announced. And the API surface area didn't grow in terms of actual control. Like, it's pretty much the same, more or less.
Yeah, from what I'm seeing of all the mobile apps that I worked on, is like the subset of controls that you actually need is quite small. Like rarely you need more than like some layout, some labels, some text, some inputs. But basically that's it.
Boxes and text, that's basically almost all layout. Boxes and text and images sprinkled on top. Like that's more or less, that's it.
Yeah. So yeah, it makes
At
sense
least for the apps I worked on, that's for the most part was true. So one thing that I think is kind of appealing in that idea is that to actually say, you know what, we're going to take control over native primitives. We're going to use native primitives, but we're going to take control over that. So essentially what we can do, we can have an easy port to the web. Yeah, actually Frank Kruger did like really interesting thing. He implemented kind of render for Xamarin Forms that renders to HTML primitives like divs and stuff. So Avalonia is probably going to do different things. They're going to use WebGL to render stuff. But essentially, web platform can be achieved relatively easily with like a specific subset. For example, there is a React Native Web. And React Native Web is essentially using React Native API to render HTML. In that project, actually quite successful. For example, current Twitter is written in that technology. And the guy who work on Twitter to actually do that actually works at Facebook right now. I use React Native for web at one of my companies. Essentially what we had like a project that is Android, iOS, and web. And it all works the same from the same code base. There are like kind of specifics. For example, this file is for web, this file is for iOS. There were like some specific because it was a video player app, but with the same API, with the same like kind of layout engines and whatnot, it was literally the same code base for all three platforms. And so web is appealing because the rendering to WebGL, that's actually what I do at work, I render to WebGL, suffers also all the issues like accessibility, focusing, browser APIs and stuff like this. And so if you render to HTML, you have actually a lot of freedom to like not to do this kind of things. You can get a lot of stuff for free. And so my opinion is to go render to HTML is better. For example, what Blazor does, right? Like Blazor, its own framework. But if you think about Blazor, it essentially say, here's a virtual DOM, here's a developer experience to author HTML in .NET. And so if we choose that route, we can do exactly the same, basically use WebAssembly as a target, but do the diffing, for example. Diffing, reconciling, and all of that is done for us. Basically, we don't need to use Blazor. We can only use WebAssembly target. And so that actually becomes really achievable, like in my opinion. And so a lot of people actually would be interested in that, again, because everybody needs Android, iOS, and website.
Yeah. Yeah, I think that's a good point. And like this is way like easier. I guess we can just even start with one platform and just build from there.
Yeah. One, again, good thing about this is that we have a reference implementation, meaning that we have reference from React Native API. Also, we have reference for the code because it's open source, meaning that we can see exactly what kind of controls to bind to, what properties to the set. I'm not saying that we should copy paste exactly, but I am saying that there is a precedence for that effort, which is good.
And we like now with .NET 7, we have all the infrastructure to be able to build for iOS, for Android, for web, for desktop. And like you said, we already have all the platform-specific APIs that are already like put in a way that can be used without relying on each platform, like with Maui Essentials. So I'm not sure in Maui Essentials can come by itself. I still need to check that if we'll not pull in all Maui.
Yeah, there's opportunity to fork. There's Uno. Uno did exactly the same thing. Like they have Windows API, Windows, what's that? RT?
WinUI, yeah.
WinUI APIs
Yeah.
ported to every single platform. Maybe that's a better route, but if nothing else, we just can copy paste pieces out of it. Like because they already did the bindings. I think that the binding is the hardest. The actual surface area is probably a little bit easier in terms of like what exactly data you get in and out. But the bindings are hard. And essentially thinking about like how this API might look like on a different platform, both Maui and Uno did that kind of mental work of kind of analyzing which API can be compatible and which API can be exposed. I think they actually exposed like file API on the web, Uno specifically. You saying like you can use files on the web, like it works. Like I think it's kind of interesting because they choose that kind of abstraction. Not necessarily right, but like they have that abstraction layer. Therefore, it's just like, oh, you know, they have local storage. Why not use local storage on the web? Anyways, okay. I'm done talking. Any other questions, concerns? Like here's my preparation. Here's my pitch, right, so to say. Not elevator pitch, but a long one.
Oh, but I actually like your ideas. Like it's so it wouldn't be some drawn UI, but without actually drawing on Canva and stuff like this. Just using the primitive of each platform. Understood correctly. Yeah. So yeah, we can try. I guess we can make some experiment like we did for version 2 when we were starting to work on it. Basically, make a small project, see if we can actually like first draw some stuff on the screen using those primitives, and then like try to plug all the Fabulous engine on it to get some diffing and.
Yeah. I think it's doable, and also I think we can really spike and experiment really quickly to just have like a proof of concept, like we can put a label with that idea on the screen. I don't think it's going to be outrageously long or hard. One thing I want to note, and this is kind of important, because we're talking about Flutter, and so what Flutter does really differently than any other engines that I know, UI engines, they actually have 3 separate notions. The one are widgets, and widgets essentially are DSL that we use in Flutter, or not Flutter, Fabulous. Sorry. So then they have widget tree, and widget tree essentially is a tree structure that kind of unwraps into that, and we have view node specifically analogy in Fabulous. View node is essentially widget tree in Flutter, but then they have another tree, and another tree is called render tree. And the idea for a render tree is that to render stuff, you don't need to have a more complex hierarchy. For example, if you have stack, but that stack doesn't have any visuals, and actually pretty common. For example, or in Flutter, you have like a component of this padding, and you put a child into padding, and all of a sudden the child has a padding, right? And a space around it. So from a rendering point of view, that padding doesn't make any sense. Like there is no conceptual hierarchy to introduce a padding. Basically, in render tree, they collapse layers like this. Basically, if you don't need like a separate layer, they collapse. And it's kind of nice because if you are talking about Android specifically, React Native actually met that issue. With Android, you create a bunch of views or Android views for each, box that you put in the DSL. And it's slow because actually creating views in Android is slow, or slower than iOS. And what they did in Android specifically, they basically introduced collapsing optimization. Basically, say, okay, if it's just layout without any visuals or whatnot, we're just going to collapse that node in hierarchy. And to do that is optimization in React Native as post-rendering.
Mhm.
So you don't have to do that with iOS. iOS, for the reason, is faster, as it usually is. But they did surface that problem. Like they did, like, oh, we can't do that in Android, so we have to be smarter. Which things actually have visuals, and only create those. So Flutter did that from the beginning because they maintain separate things. I'm not sure, like, if we should pursue that or not, but I do know, like, in my apps, there are a bunch of stuff, like a bunch of wrapping that don't have visuals. And so one of the big performance wins specifically for Android would be not to create views or native controls for them. And so I'm not sure, like, if we should actually do it, but at least we should consider how that optimization might look like as a first-class citizen.
So yeah, actually, I was thinking of this. Like, it's what I'm pointing in one of declarative capabilities. Basically, it's like like the layouting, especially like you said, spelling, is to if we want to be more declarative, I think we need to be more like Flutter and put the layouts as a node in the widget tree. But indeed, to be more performant, we need to have another render tree where we will only have the controls and primitives that we want with the right margin paddings and positions. So I guess having these three trees in the widget tree, the element tree, and the render tree is quite important also for us.
Can be. We didn't do that for Fabulous right now.
It's more or less the case actually. It's we have the widget tree in Fabulous, and then the element tree is like Maui, combined forms, and then
Exactly,
there's the
exactly.
render on the side.
Yes, but Maui doesn't support that, like not creating instances of views. But in practice, we do have them, but that kind of the third element tree is Maui, essentially, and kind of a little bit implicit for us. And so the idea is, like, what if you make it first-class citizen? Like, what if you make it like explicitly as a part of the core architecture?
Yeah, like
How
this we
that
can
might look like.
optimize. We can optimize like how we want, and if we want to put a new widget that is specific for a certain layout, it will be transparent for the render.
Yeah. Also, one of the things that came out with, like, that kind of both from React web world, React native world, they have a concept usually of a layout components. So those components, they don't have any visuals, but they introduce layout. For example, padding from Flutter is a good example of this, or vertical stack. So a common pattern is to say, here's a scroll view. Inside the scroll view, you have stack, right? And then you can scroll. So that vertical stack actually doesn't have to have visual, for example, at least for the most part. And so in React Native, what they do is they don't have explicit notion of, like, you have a visual, you don't have a visual, but like if you create a view, in view is the most primitive, it's a box. By default, it doesn't have anything, basically, unless you put a border or a color or a background color on it, it doesn't have it. So on the one hand, I really like what Flutter did, basically introducing padding as like its separate component. On the other hand, every single nesting like this, for them, it means several cache misses or CPU cache misses when you traverse a tree. Basically, it introduces more nodes in the tree traversal and chasing pointers if we're talking about 1,000 elements. And usually, complex UIs are about 1,000 to 5,000 elements on the screen. So basically, these padding components can multiply that by 2. And chasing 2,000 pointers, all of a sudden for CPU, and specifically for mobile CPU, because they're like L3 or L2 cache on mobile CPU, they're so small, that can be really problematic. Even though I do agree it's a nice API to work with, but I didn't know, like, if you can afford it from a performance point of view. So React Native decided that they can't. Flutter decided that they can. I'm hesitant. I feel like there are pros and cons to this, and con is performance is a big thing.
Maybe we can find a middle ground, like only introduce those extra nodes in certain conditions. I don't know.
So, Tim, I think you're more familiar with Swift UIs than I am. I haven't professionally programming Swift UI. What do they do? I think they have padding as a attribute, right? They don't
Yeah,
have
but
padding as a
so what they can do, like basically they are like doing it like us, or you can add a modifier to the widget.
Mhm.
But what they do differently is you can call several times the padding, and it will apply like it's like in an additive manner. So say you have an image, you say my image has a padding, my padding as a background, and then there is another padding around my background. So you can just like change them like this, and they will just add everything together.
Oh, that sucks. I'm sorry, but it's kind of really unpredictable.
Yeah, so
Yeah, I
it's
feel like
the order of the modifiers really matters in Swift UI.
the order of modifiers, like we should try as hard as possible not to make them matter. As hard as possible.
I'm not sure actually like how they achieve this. If they somehow just return another control that perhaps the other one with a padding or thing
So
like
as far as knowing Swift UI, they call it the immutable UI. So every time you apply a new modifier, then the result is a new struct, a new UI version of a new UI, let's say version of the same view. So it will create a new one, but they all only use structs for.
That is true, but also not true. Basically, in order to keep all this attributes for them, they have to keep allocate. Basically, they have to have a collection to hold all the properties that you specified. And so by default, when you create a view, it's a struct, meaning that it's a stack allocated. But when you start to put stuff in, because you don't know how many things are in advance in that struct, so they have to keep allocate at least some of them. And there are some optimizations to do it a little bit more efficiently. For example, say you stack allocate 4, and then if you add fifths, that is going to go to the heap. Actually, what we do, but only 3. But like there's a cost to kind of like add stuff because it will introduce heap allocations. So I didn't know because Swift UI is a reference counting, meaning that it's a atomic heap allocation. And then immediately deallocation. So maybe they have like allocators that are really optimized for this. But in .NET, because it's goes to GC, it will probably introduce more performance hits. So basically, like probably in .NET there is more performance impact than in Swift UI. At least that's my intuition about this.
Yeah, and like we saw on Android, it really matters to not allocate too much.
I think that allocate is one. By the way, in terms of allocations, I have some ideas in terms of fabulous internals, how to basically try to avoid allocations a little bit, maybe significantly. But actually, I have a question for you, I guess, and for you, Edgar. So what you would think if we add a requirement that you have to pass like a scope or a context, basically an argument for each container. So each container, like vstack or whatever, you need to pass like a new argument. Basically, it's an allocator. And say allocate there. So from an API point of view, it's going to be ugly. From a performance point of view, it can be a huge win, meaning that if you pre-allocate space in advance, you don't need to allocate as much. But essentially, like you have to carry an argument around, or it can be somehow done as an implicit argument. But I didn't know how to do implicit arguments in Extract.
Yeah.
I think there is no way.
Like the way it was done on Fabulous V1 is we were using like optional arguments to the widget basically, and like since it was in line, the whole thing was in line, it would be like the compiler would just get rid of all the optional arguments that were not set, and every one of them was just basically doing like +1, +1, +1, +1 and then it was just allocating the right side of the array to set only the attribute that matters.
But it's still allocates, right? It's still allocates per widget.
Yeah.
So what I did in my kind of day job, Rust, my day job is in Rust, and so Rust is a really different beast because it has lower level control over memory. And so what I do is I use arenas, meaning that for the most part there are 0 allocations for pre-renders. Basically, when you change UI, I allocate the widget structures in one contiguous array called arena, so arena allocators. So allocate them, and when I re-render UI, I allocate in a new arena, and then when I'm done, I swap. So basically, I have 2 arenas for old UI, for new UI. I calculate diff, and diff actually calculates into another arena. And then when I'm done, I swap these 2 and I reset diff. And basically, this allows me to have 0 allocations for most of the, basically for the app as a whole. Because arenas, they can grow, and then you can reset them, but essentially, like, they occupy some space, like hold memory. And if you might imagine, actually pretty fast. And so what I'm curious about is, like, is there a way for us to kind of at least use some of the ideas of arena allocations, meaning like here's going to be allocations that we know are going to be really fast and cheap. Let's say, widgets, right? Like widget builders and widgets, right? They're really transient, really temporary. And so what I'm thinking about, like, can we somehow optimize allocations for them? Meaning that at least for the render, you don't allocate. Basically, render call doesn't allocate. Maybe not at all, but like probably at least somehow bring it down a little bit.
So there is a concept of shared arrays in .NET, where you can say, like, I want to allocate this much, and then you can just keep reusing the same one and free it when you're done with it.
Essentially, it will require like a reference to that array or whatever. Like, basically say, I need to pass that thing around where I allocate to. And it can be done implicitly, like through a static, like what Avalonia did. I'm like, sure, like what can go wrong? Like if you put static mutable variable that is kind of used everywhere, right? Or we need to be more explicit, which is my, I guess, bias. But I'm not sure if, like, from ergonomic point of view, is going to be good. One thing I'm kind of considering is that when you call compile, basically what we need when we call compile needs to have an argument. And I don't know how to achieve that.
And to pass it, I don't know, because you will need it every time that you need to call compile. So it will be in a lot of places.
So basically we have the DSL, right? And in terms of DSL, the very top node is going to be like application or whatever. Like we know there's going to be a collection builder. And so what we can do, we can say at the very top level, at least that would be my preference. At the very top level, you say, here's an arena for you to allocate into, or like, here's the scope for you to work with. And that's it. The only top level has an argument explicitly. And then it implicitly passes into compile children. So when the children compile, they implicitly get that scope. It can be ugly, meaning, for example, we have yield, right? So yield is when we actually collect the digit, right? And so maybe when we yield, we say, oh, when you yield, you actually need to put in your allocator. Is it like?
What about maybe using it as the last modifier? Let's say we are in the root of the app, in the application widget. We can maybe have a last modifier that will actually run or do what you are suggesting. Basically saying on the top level you need to define an extra modifier that will make compile the app or will compile the DSL. So that way that will be available.
The problem is compile is called last, meaning that you call compile for all the children before you call compile for the widget builder, basically for the collection builder. So in terms of sequences, you pass in arena or whatever scope into collection builder, and then all other children will be called with compile, and then the parent itself will be called with compile last. And we need that allocator, or like we need a scope at compile, meaning that every single child needs to get it, and it needs to get it before the parent gets compiled. And so that's kind of the challenge that I have in terms of API, but maybe there is the opportunity actually to do. So if you can make it nice, I can probably make it like almost 0 allocations.
Yes,
Well,
it's interesting to
not almost, but few, because some attributes require heap allocation. For example, in Maui, if you use Maui color is for whatever freaking reason is heap allocated. Why? I don't know, but like that's the nature of the beast. Some of the properties, specifically in Maui, cannot be done like this. So they're still going to be heap allocated. But if we're talking about Fabulous v3, and specifically like if you design our own toolkit in a way, we can actually make sure that all the attributes are stack allocated or can be allocated on the stack. And so if you can do that, then we got reduce allocations by like 10x. At least that's my intuition right now. And if it does that, that will probably really compete favorably with any other existing frameworks, specifically Maui. I think that out of the box, we're probably going to be way faster than Maui due to all the dynamic dispatches. So Edgar, if you don't know the internals, I think it's kind of really interesting of Maui. So what they do, they have events, and events are always boxed. They're always objects. They're always heap allocated. Even that property, like, I want to change integer, like a slider, and slider is float. I want to change a slider. So they box that slider into a heap allocated object, and then they unbox it. And they do that regardless if it's a integer, float, whatever. And partially because of that, Maui generates a lot of pressure on GC, and also it has a lot of heap misses or cache misses because of that heap allocated objects. So what we don't do, which Maui does, is we have a special treatment for small scalars, right? Like floats, for example, they're not heap allocated. When you say, padding 5, not padding, maybe font size 5, for example, is a good example of this. That 5 is just being put into stack allocated structure. So out of the box, just because of that, we can make it way faster than Maui. That's it. I'm done.
Yeah.
Sorry.
Just
Awesome
trying to
stuff, yeah. Awesome stuff. I love it.
yeah. Just not sure how to implement it though, but yeah, would be nice to have this one.
I have ideas, so let me actually try to play with it a little bit. So I'm still porting my app into Maui controls because I want that to be available on Mac. It's still going slow, and so when I started to work in the app, and then I'm like, okay, I need to try to improve Fabulous as well and try to help Chin. And so that's when I'm like, okay, let me pause my app. Let's actually try to build a better Fabulous, and then we'll go back to my app. I didn't get back to my app. So Fabulous V2 is out or whatever, but I didn't get back to my app. So I'm still porting it to my controls. And then I'm like, okay, now let's try to sketch out Fabulous V3. And then maybe after V3, I will finally port it back. Maybe.
So let's try to wrap up a little bit. So it would be nice to put, I guess, to put in writing some of the stuff that we just talked about, like, and then to try to make some spikes. But what we said with the primitive on the platform, and improving the
One thing I'm
allocations.
kind of really hesitant is that I actually did say not maybe super nice things about some service aggregators and stuff, and you did record it. And so now we have like a video proof of me being not nice. That's actually a bummer.
Yeah. Okay. So I guess we can just wrap up a little
No,
bit.
that's
And
fine. I feel like Volonian people probably can forgive me for that. I hope so. They will.
okay, so thank you everyone for participating. Let's see you in the next office hour of Fabulous. Like hopefully it will be next month sometime to see you then.
Yeah, I think we lost most of the people, but at some point there were 10, 11 people in the chat, which was really good. So yeah, we have a good audience. So yeah, thank you very much, Simon, for taking the time. Timothy as well. Yeah, we will be doing more of this in the future, and hopefully we can evolve and discuss and learn all together.